In today's lesson, we're going to look at how pollution contributes to the formation of photochemical smog, particularly in our major cities. Okay, so starting with what we need to know in our science understandings. Nitrogen oxides are formed in high temperature engines and furnaces. We'll talk about that more. We need to be able to write equations for the formation of nitrogen oxides, NO and NO2. So that's nitric oxide and nitrogen dioxide. Nitrogen oxides and ozone are pollutants in the troposphere that are associated with photochemical smog. So we need to be able to describe and write equations showing the role of nitrogen oxides in the formation of ozone in the troposphere. We need to describe the harmful effects of nitrogen oxides and ozone in the troposphere. And we need to be able to describe and write equations showing how catalytic converters reduce the quantities of nitrogen oxides generated by motor vehicles. So let's explain a little bit about that. Firstly, just a few key terms. When we talk about the troposphere, we're basically talking about the lower part of the atmosphere. Photochemical is basically a chemical process that's caused by light, and generally sunlight, but there are also some other photochemical processes which rely on things like UV. Certain glues will only cure under UV light. And photochemical smog is a mixture of chemical pollutants that are either released directly from the source, like your car exhaust, we refer to those as primary pollutants, or formed as the result of chemical reactions in the atmosphere. We refer to those that are formed in the atmosphere as secondary pollutants. And the photochemical smog often forms a brown haze over large cities. Probably most importantly, let's really focus on the equations and the chemistry, because that's the most important part, as you can see from the curriculum outline. So firstly, you may or may not remember, but air is primarily made up of two gases, nitrogen and oxygen. And then there's about less than 1% that makes up all the things like the greenhouse gases like carbon dioxide and methane and lots of other things as well. But as a fairly good approximation, we can say that air consists of about 80% nitrogen gas and about 20% oxygen gas. And when we burn when we use air to burn fuels in car engines and furnaces and that sort of thing, we're not only putting the oxygen in there, which is the main thing that reacts in a combustion reaction, but we're also putting nitrogen in there. And when that happens, some of that nitrogen will react with the oxygen. So if you like, the nitrogen almost burns, it's oxidized itself to form oxides. So we will get N2 gas will react with oxygen gas at high temperature to form, and we need a 2 there to balance that, so to form nitric oxide. Now, what happens though is when that nitric oxide gets released from, for example, the exhaust of our car, that can then react, with oxygen in the atmosphere to form nitrogen dioxide. And that's typically the main contributor to that brown haze that you would see above a city that's experiencing smog. So if you like, the nitric oxide that's released there is our primary pollutant. The nitrogen dioxide is a secondary pollutant because it's formed from the reaction of the nitric oxide. But it doesn't stop there. Sorry, I'll just go back and I should balance that equation for you as well. That nitrogen dioxide, when it's exposed to light, so this is where the photo in photochemical comes in, will break apart to form nitric oxide again, plus a free oxygen atom. Now this free oxygen atom doesn't, if you like, survive or last very long. What that very quickly does is that reacts with another O2 oxygen molecule in the air, and that forms O3, which is what we know as ozone. So that's, if you like, the third major component of our photochemical smog, and that's also a secondary pollutant. So firstly we form the nitric oxide, then we form the nitrogen dioxide, and then that nitrogen dioxide then leads to the formation of ozone. Now this process, the other component of smog is what we call volatile VOCs. And VOC stands for volatile organic compounds, and they are mainly unburnt fuel that comes out of the exhaust pipe of a car. And these, as I said before, also contribute towards the smog problem. But the most important part is this process here that happens with the nitrogen oxides and the ozone. Now, this smog won't just form anywhere. You need a combination of conditions for you to get that really intense, or that brown layer over city where you get, those sort of dangerous smog conditions. You need to have a high concentration of pollutants, so lots of traffic, lots of cars, or really lots of industry that are, combusting fuels. You need to have, obviously, sunlight. In the lack of sunlight, you might get the nitric oxide formed, and maybe the nitrogen dioxide, but it definitely won't go on to get the ozone form. You need very still conditions. If there's wind, the air is moving, these gases will tend to dissipate before they reach a stage where they can, produce a significant amount of smog. And along that same line of still air, you usually need what we call an inversion layer. So normally warm air, which is less dense, so as something gets warmer, it becomes less dense and rises, hot air rises. So normally warm air near the surface will rise. But if air at the surface is cooler, and therefore more dense, because the cooler air is more dense, then the air above it, the air at the surface won't rise and it will be trapped there. So if we get this cold layer of air at ground level and then warm air above it, that cold air isn't going to obviously want to rise because there's already warm air above it, so it's more dense, more heavy. It's just going to sit there nice and still on the bottom. And that's going to allow for these conditions to allow us to get these high concentration of pollutants and therefore to get photochemical smog. There is something we do though about trying to lower the concentration of nitric oxide and other compounds, the volatile organic compounds that cause smog, and that is that we have catalytic converters, which are part of the exhaust system of most modern cars. And what happens in a catalytic converter is that the nitric oxide will react with another gas that gets made in our cars where we don't have complete combustion, and that is carbon monoxide. And when those two things react, they will form carbon dioxide. Now we know that's a greenhouse gas, but it's not toxic like carbon monoxide. And nitrogen gas, which is, if you like, a relatively harmless, naturally occurring gas in our atmosphere. Just balancing this one, it can be a tricky one to balance. We need a 2 there, I think. We need a 2 there and a 2 there. I think, yep, that should balance out. So that's the reaction that happens in our catalytic converter that removes some of the nitric oxide so they can't go on and make smog, smog and also removes some of the carbon monoxide. Now, the most important thing you need to do here is, says up here, write equations showing how catalytic converters reduce the quantities of nitric oxides, which is what I've showed you here. The catalytic converters, though, will also react or oxidize. Oops, sorry, that's the wrong size pen. The catalytic converters will also oxidize the some of the volatile organic carbon, so some of that unburnt fuel will get oxidized so that it doesn't get released out the back of the exhaust pipe. And they can also, as well as reacting the carbon monoxide with the nitric oxide, they can also oxidize, sorry, it's just pen's being a bit silly, the carbon monoxide, so that we reduce the amount of carbon monoxide as well that's coming out of our exhaust. Why do we want to stop smog forming? Obviously it doesn't look very attractive, but more importantly, some of the harmful effects of photochemical smog are it's a respiratory irritant. So those three, nitric oxide, nitrogen dioxide and ozone, are all respiratory irritants which can affect breathing and cause damage to the lungs. They also inhibit photosynthesis. So photosynthesis is the process where leaves taking carbon dioxide and, well, plants taking carbon dioxide and water and convert it into carbohydrates like glucose and sugars, and also produce oxygen gas, so lowering the carbon dioxide concentrations in the atmosphere and increasing the oxygen concentrations, which we know is important from the last topic. Now what happens here is they basically, the ozone in particular causes the guard cells in the leaves to close, limiting the exchange of gases required for photosynthesis, so carbon dioxide in, oxygen out. And it also acts as an oxidizing agent which further disrupts processes in the cell. So you don't necessarily need all that detail. You've just got to, I think it says here, describe the harmful effects. So the idea that it inhibits photosynthesis, which then obviously has detrimental effects on plants, would probably be enough detail in a test or exam. The other thing is that ozone in particular will cause perishing of polymers or plastic. It will react with carbon-carbon double bonds in polymers and cause degradation and cracking of the plastics made from polymers. When we look at the organics later in the year, we might come back and revisit this, the chemistry of this. You may have done polymers last year and be familiar with that also. Once again, it's only a describe feature here, so you don't necessarily need to remember all the fine detail, but I guess mainly that it can cause perishing of polymers, which leads to them cracking or degrading down faster or losing strength or something like that. You don't necessarily need to put all the chemistry in because it's only a describe. So just to finish with a couple of other interesting points related to photochemical smog, this process here, or particularly at least with the nitric oxides, also can occur naturally in lightning, and it also can occur in volcanoes and bushfires, which I know sometimes bushfires are natural, sometimes they're not natural. And in those cases, it can have an important role in actually putting nitrogen, dissolving nitrogen into the rainwater, and therefore that nitrogen will act actually as a plant fertiliser, and it will make crops grow better, or your lawn will grow better if it rains when there's a thunderstorm. This isn't really part of the course at this point, but I just think it's interesting to point that out and the similarity there. Ozone also, another place you get ozone produced is in photocopiers. The really bright light in photocopiers, combined with the high strong electric fields that are used to make a photocopier work, will also produce ozone. So you'll often get that sort of characteristic smell of ozone around a photocopier, and that's why it can be a little bit dangerous to hang around a photocopier too long, because that ozone is a respiratory irritant. Okay, bit of useless information for you. Thank you.